Happy Monday. Today we are introducing the concept of factoring a trinomial that does not have a greatest common factor, is not a difference of squares, and has a leading coefficient greater than 1. And that leading coefficient, we're referring to this number here in front of the x squared. Up until now, you've been factoring trinomials with no leading coefficient, or leading coefficient of 1. But now we're going to start seeing numbers in front of that x squared. So let's look at what this looks like with the algebra tiles. So here is the setup. You can see here we have 2x squared plus 1, 2, 3, 4, 5x plus 1, 2, 3. So that is our trinomial, 2x squared plus 5x plus 3. Okay, so then let's take a look at what are the two factors that create this rectangular product. And if we examine the outside here, we'll see that we have 2 x's plus 1, 2, 3 units. And then we have 1x plus 1 unit. So the two binomials that will work would be 2x, plus 3, and x plus 1. Now let's check that out. So we have 2x times x, we get 2x squared. 2x distributed to the 1 plus 2x. Then we get the 3 distributed to the x plus 3x. And the 3 distributed to the 1, and you get plus 3. Put it all together, you get 2x squared plus 5x plus 3. So the two binomials, the two factors that create this product, are 2x plus 3 and x plus 1. Well, Mrs. Evans, if I'm going to deal with large numbers, or if I'm going to have a bunch of different integers, or I mean, you're not expecting me to use algebra tiles every time I need to factor something with a leading coefficient, are you? No. I wanted to show you how this worked with the algebra tiles. All we've done is everything we've done in the past, but we've added another x squared on, or however many x squares are going to be our leading coefficient. But let's take a look at what this looks like with another example with a different leading coefficient that maybe we wouldn't use algebra tiles for because it would just get too large and clunky. Okay, so here we have a trinomial that we cannot pull out a JCF. We do not have a difference of squares, and we have a leading coefficient that is greater than 1. So we need a new tool in our tool belt. I'm going to teach you some steps to factor this by grouping. And to start off, you understand that when we had only a coefficient of 1, we look to the C term. Remember, this is term A, term B, and term C. We look to the C term to find the factors that when multiplied equaled the C term, but when added equaled the B term. Well, now that you have an A term that's not 1, you also need to consider the A term when looking for the factors to multiply. And so what we're going to start off by doing is multiplying the A and the C term together. So step 1, multiply your A term times your C term. Okay, so now I have my A term multiplied times my C term. I get 30. And now I have to think about all the factors of 30. Well, 5 times 6 and 3 times 10 and 2 times 15. And oh, look, if I have a negative 2 and a negative 15, that's going to add up to negative 17. Those are going to be the two factors I need. So the second step then is to rewrite your polynomial as A term, B1 term, B2 term, and C term. Okay? And what does that mean? It means bring down the A term. Now minus, we'll say 15m minus 2m plus 6. Now the reason I organized them that way is because now I'm going to start to group them. So step 3 will be to group the first two terms and then group the second two terms. And by grouping them this way, I can see a GCF in each of these groupings. If I put the negative 2m first and the negative 15m second, it would not have been easy to find a GCF. So now I'm going to look at pulling out a GCF. Well, what do these two terms have in common? Well, they have a 5 in common and they have an m in common. So that leaves me, if I divide 5m squared by 5m, it leaves me with m. If I divide negative 15m divided by 5m, it leaves me with what? Minus 3. Next, if I have a negative 2m plus 6, what can I pull out? Well, of course, I could factor out a 2, which leaves me with negative m plus 6. Or sorry, plus 3. Okay? Now, there's one caveat here, and that is I need both of these binomials to match. Because these two binomials are going to work together to be one factor of the product, the total trinomial up top, this big trinomial here. So they have to work together to be the same. All right, how do I do that? Well, I'm going to factor out not just a 2, but a negative 2. And then that means when I divide negative 2m by negative 2, it leaves me with just m. And when I divide positive 6 by negative 2, it leaves me with minus 3. In which case, I now have two matching binomials. Okay? So, now what? Well, if you recall, if we have this set of binomials to multiply, let's say we were to start here, even though this is our finished set of binomials, this is our factored set of binomials, right? We took this one to create this binomial, and we took these to create this binomial. Well, let's say I start with this set of binomials and I wanted to multiply. What would I do? Okay, I would distribute the 5m to the m and distribute the 5m to the negative 3. Okay, and I would distribute the negative 2 to the m, and I would distribute the negative 2 to the negative 3. Well, that's what this is saying here. That's what this is saying here. Here I'm distributing the 5m to the m and the 5m to the negative 3. That's this first one here. And here I'm saying I'm distributing this negative 2 to the m and the negative 2 to the negative 3. So we're just undoing it in reverse. I know that's a whole lot of new at the same time. But the only way to get familiar with it is to keep working with it. Okay? So step 4, once you had grouped the two terms, you were going to, 4, factor out the GCF. Factor out and divide by GCF. Okay? And so when we did that, we were here, and I think you guys followed along great to that point. We factored out and divided by a GCF. So we took the 5m, factored it out, and we divided each term by the GCF. 5m squared divided by 5m is m. Negative 15m divided by 5m is negative 3. That's what's left over, right? Here we divided out a negative 2. We factored out a negative 2, which left us with m. 6 divided by negative 2 was minus 3. Okay, now we're saying this is one factor that when multiplied gives us this trinomial, and the other factor is this one here, 5m minus 2. And the reason it's written this way here, broken up, is because it's in the process of distributing going this direction. Coming this way, it's undistributing. That's not really a term, but it's factoring. That's what undistributing is, right? We're factoring it out coming down. We're going the backwards direction from the multiplication. Now we can test our final answer by simply remultiplying. 5m squared minus 15m minus 2m plus 6. Isn't that what we had up here? Okay. Then we combine the two middle terms. And this is where we started from. So what's the final answer? What answer are we actually looking for when we do this? The answer we're looking for is right here. We want to know what are the two binomials that, if multiplied, would give us that trinomial. Factor the trinomial into two binomials, and that would be these. So after you, let's look at our steps one more time. So after you factor and divide out that GCF, divide by the GCF 5, you're going to rewrite in terms of two factors. I should say rewrite binomials in terms of two factors, which is this step here. If you followed all that, first off, you deserve a gold star. You can try example 3 on your own. Pause the video, try it on your own, follow the steps that we've written out, and see how far you get. But if you're not ready to fly solo yet, no worries. Let's do number 3 together. All right, number 3. First step, multiply your A term and your C term. Second step, find the factors. I know it's negative 8, positive 3. Next, rewrite polynomial and group. 6y squared minus 8y plus 3y minus 4. You might say, well, where'd you get the y's, Mrs. Evans? Well, remember, we're trying to create the y term, right? We need two addends so that they are like terms, that you can combine them and get that minus 5y. We're creating the b term, which the b term is the y term. Okay, now we group the first two terms, the second two terms, And now we factor out a GCF, step 4. Factor and, well, really should say, and divide by GCF. So what's the GCF in the first one? 2y. Leaves you with 3y minus 4. Hey, look at that. They're both 3y minus 4. So what would be the GCF that we would divide out in the second binomial? Well, it's just going to be 1. Will it be plus 1 or negative 1? It'll be plus 1. So now, rewrite in terms of two binomials. 2y plus 1, 3y minus 4. That's it. That's all there is to it. If you remultiply that, you'll see you'll get the first trinomial at the top. All right. Now I really do want you to all to pause it. Try example 4 on your own. Then unpause it and work it with me. Excuse me. Okay. Assuming you've paused it on your honor and you've tried, at least got as far as you can. I'm getting negative 60. That would be 15 and negative 4. Now I'm going to write 12c, right? I'm bringing down that a, 12c squared, plus 15c minus 4c, creating that b term, minus 5, just bringing the c term down. Now I'm going to group it. And now I've got, well, what can I pull out from my GCF? Well, 3 definitely and c definitely. Okay, now here I have a negative 4c minus 5. And remember, they have to match. So I can factor out a negative 1. Okay, that will leave me with a positive 4c plus 5, which then lets it match. All right, and then last but not least, rewrite them as two binomial factors. Always check your work. 3c times 4c is 12c squared minus 4c plus 15c minus 5, 12c squared plus 11c minus 5. There's my initial trinomial. So my answer then is 3c minus 1, 4c plus 5. All right, now work on your own and put your answers into the Go formative.